Hi, my name is George Barbu. I'm with EPSON Robotics. I appreciate you taking time out of your day to go through this. One of the goals of our mini seminar here is to show you some of the basics and the fundamentals of robotics. Go through some of the details of EPSON and the different types of robot EPSON offers. And then get into robot selection based on your reach and based on your payload. We go to the website, and then from the website we decide to select a certain type of reach robot, download the CAD files to determine what robot we have to use for our application. Afterwards, we're going to start into the robot programming by going to the robot manager. After we go to the robot manager, we're going to jog and teach the robots to several locations. Teach a pick and a place location. After you teach a pick and a place location, we're going to get a little more intricate and teach a few spots so we can actually write letters, EPSON, or one of the letters, by using several commands, including jump, go, move, arc. When we get comfortable with teaching those locations, we modify those through the robot manager. We modify those points either through the robot manager or the point file, and then we actually write our first robot program. We get intricately more experience in the robot program by having an infinite loop, having a timer, having a wait. We add inputs and outputs, and we try to make this as much of a real-world robot program as possible. After we do that, we have a palette that we teach. We also then do a robot simulation, so you realize how when you go back to your office, you can drop a robot in your work envelope and teach a couple basic spots and get some type of rough cycle time. We appreciate you taking time out of your day to do this, and wish you a great robot application. If I go to my screen, I have in help, I told you guys about the different manuals. I have EPSON RC 5.0 User's Guide. That's a huge manual. It's got everything that you guys saw in here previously, where it tells me my LIMZ, all the points, all the commands. I told you guys when you buy an EPSON robot, you don't just get the manual for the controller that you have, for the robot you have. You have the help and the manuals for all the robots as long as you load it. Sometimes some guys may not load it all on their current system, but you have the manual for the teach pendant, the manual for the operator interface, the manual for the G1 robot, G6 robot, G10, RS robot. I have the manuals for the RC180, RC90 controller. So I have all the manuals, even for the robots I'm not using. So we'll go to our laptop, and we'll open up what looks like EPSON 5.0, not the simple, just EPSON 5.0 for most of you, and for Ricardo, you're going to open up EPSON 7.0. So if you want to double click on EPSON RC Plus 5.0.
Yeah, go ahead.
It opens up and tells you your tip of the day. What will happen is it'll open up to the last known program. So now you'll open up, you go from connection offline on the right hand side to USB. That'll connect to our robot controller. We'll also go to project now. We'll go to project and select new and give it a name. Don't use test, don't use sample. Type in your name. So this is Windows certified software. What happens is there's like 5 or 6 ways of doing the exact same thing. The way you learn it the first time is the way you do it. So I always know that when I start a brand new project, I go to project new. There's other ways to do it, I'm sure there is, but this is the way I know how to do it. What that does is it opens up a brand new program. In my case, I called it Hello. If you cruise the top of the toolbar there, you have these pop-up windows. And I want you to feel comfortable. The goal is that today I'm going to show you things, and you're going to forget a lot of this stuff. But I want you to feel comfortable when you guys leave here, that you guys go back and modify that program, start a brand new project, teach points, move the robot around in different ways, and we're going to see how far we go depending on what the class pulse is like today.
Guys, what you want to be doing here, what it does, it sets up the program function name is the beginning of the program, fn is the end of the program. So you're going to fill stuff in the middle. So you want your cursor in the middle, and we'll fill the program information in there.
The first thing generally people want to do is they want to move the robot around. So if you click on Robot Manager, it says, warning, the project and the controller is different than on my PC. Do you want to overwrite it? In our case, we're going to say yes, because we're not in a production environment. I want to click on reset. The first thing you want to do is click on reset in case there is an e-stop that was hit. Then motor on. And you should have the light on your robot will come on. Let's try that again. What I'm going to do is, you guys all have e-stops. So we're familiar with where our e-stops at and what they do. Hit the e-stops, reset it by turning it. Now click reset, then motor on, and try that again. So on this Robot Manager, we're going to be using this screen a lot. So there's control panel, there's jog and teach, there's points, there's arc, there's locals, there's tools. There's a whole lot of things that we can't even have time to cover today. What we're going to be mostly in is control panel, jog and teach, and points. So go to the jog and teach window. Now look at the screen. Look at my screen before you guys do it. So look at the screen there. You notice right now, I'm going to explain what this Robot Manager does. In my Robot Manager, I have the world coordinate system assumes the center line of my z-axis right here is where my point is at. So when I move my robot around, it assumes the part's right in the center line of my z-axis. If I pull this down to tool coordinate system, it assumes that I have a tool. And that tool could be, like I'm having here, it could be mounted to my gripper. My gripper could be mounted, and it could be offset some distance. So if you guys see, if you see this, I could have this mounted to the center line of my z-axis. My part may actually be offset some distance, 2 inches, 3 inches, whatever that distance may be. So that's if I teach a tool. And we may get into teaching a tool today. If I pull this down to joint, which is the last one, you'll see my screen changes now. Now I have J1, J2, J3, J4, and J5 and 6 are grayed out. If I was connected to a 6-axis robot, J5 and J6 would be active. Again, what you guys are seeing is the same exact thing that is on a 6-axis. Now, J1 on your scale robot is the shoulder. J2 is the elbow. J3 goes up and down. J4 is the rotation. You guys are going to get a chance to play with that in a little bit after I explain what this screen is here. If you look at my robot now, I'll change this back to world coordinate system, change the speed to high. When I move my robot around, my current position on the screen there changes. So if you look at me, I'm doing X, and the X is moving in continuous. Right now my jog distance is set to continuous. If I change that to long, I can change my 11 millimeters here to be 8 millimeters. So now every single time I move my robot in the X direction, it'll move 8 millimeters. The point is I can change that. I can change these values. They don't have to be the default. So I can change my Y instead of 5 millimeters. I can change that to be. I can change that to be 3. So now every time I move in the Y direction, oops.
Yeah, you're basically setting up the jog increment.
Yeah, so I'm saying. So every time I move, what I want you guys to see is there's different ways to move the robot around. And before I set you guys free here, there's a couple other things I'm going to show you here before I set you free to test it out. On the left-hand side of the screen, there's an execute motion command. Is everybody there? Can everybody see what I'm doing right there? Execute motion command right here. When you guys move, I want you to use jump almost all the time until I tell you guys to use a different command. And then on the right-hand side of the screen here, we're going to teach points. So I move to a spot. I got my robot to a spot. I'll teach it by clicking teach. It says yes. And it wants me to give it a label. So I'll say pick location and hit OK. So now I just taught a point called pick. So you'll see now when I go to my screen, it says P0 is called pick. So now I'll move my X. I'll move my X. Pull down a spot that's not being used that says P1 is undefined. Click teach. I'll click on teach, say yes. And I'll call it place. So I just taught 2 spots. Did everybody see how I did that? Now I'm gonna have, I would have liked to have showed you guys this is the hard way to move it by clicking X, Y, Z, and U. The easy way now is if I go to my control panel, I'm gonna go to control panel, and if I see this area right here in the center of the screen says J1, when I click on J1, everything stays locked up. The elbow and the elbow, the Z-axis is locked up, but because J1 is free, I can move it by hand now freely just in J1. If I click on J1 and J2, now my shoulder and elbow are both free. If I click on free all, now every single point is free. So now I can move the shoulder, the elbow, the Z up and down, and the U. But when you're moving the Z up and down, there's a brake release button on top. Because there's a weight on there, there's a brake release. The only brake that's on the scare robot is on top. So you push that button, allows me to move it in the down direction. So now you can move all 4 joints by hand to where you want it to move to. The thing I want to warn you there, Jenny, and everybody else, the range of my Z-axis for G3 robot is 0 to minus 150. So look at my screen here. If I go to the jog and teach window, my current position right here tells me where I'm at. You want to make sure your Z is between 0 and minus 150. If it's a positive number, it will not work in your software. Because even though the physical robot can get to higher than 0, it won't take anything only between 0 and minus 150. If you're at minus 155, especially Jenny, because you don't have a stop on the end of your Z-axis, if you're below that minus 150, it'll move there, but it won't program between that point. Again, the robot's designed to be slightly larger than 350, and the Z-stroke is a little more than 150. But I want you guys to look at your, we got our EPSON in front of you here. If you want to teach 2 spots, teach E2 and teach N4. So if you guys want to do that, I'll give you a little bit of, I'll let you guys do it on your own for a little bit, but teach 2 spots, E2 and N4, and then test those 2 points out. Actually, hold on, before we do that, let's put the gripper on. It's this one right here.
Yeah, it's got a spring.
So what we're going to do is we're going to take the marker, take the cap off, drop the marker in with the spring on the back. There's the pin, there's the solid, drop this in, torque it down just a little bit.
You got to thread it till it stops.
Yeah,
So you drop this in with a spring in the back side. You drop this in, and there's a wrench there. Tighten it till it stops.
and then put
And it
this on.
should give you a little bit of spring load on the Sharpie.
So if you want to put your gripper on, so I want you to teach 2 spots now. Move the robot to E2 and N4, either by moving the world coordinate system or by moving it by hand, whichever way you feel more comfortable. Generally, I force people to do it the hard way first, but in the interest of time, I'll let you guys teach the 2 spots. And then I want you to test those 2 spots out by clicking the execute motion command. E2 and N4. And when you name your point, call it E2 and N4. So give that your label as E2 and N4. We're going to go to our main program. After function main, type in jump, which is the command that we used, Actually, hold on. We have to close up that robot manager. When you close up that robot manager, but I ask you if you want to save the points. So you want to save the points?
You already saved them. You can also, before you get there, you can go to that points tab and save all the points that way as well.
You just want to make sure they're saved. If they're saved, what happens when you type in jump in your main program, they pop up like they do on my screen here. So I'm going to say jump, and I'll select N4, type in jump, space, and select E2. And then after that, I'm going to type in parentheses. This is my first program. Print. Now, because I'm not going to be around you guys when you leave here, I want to get you comfortable kind of cruising the top toolbar. So put your cursor on the top toolbar and look for the run window. And there's like 3 different spots. Again, it's like Windows. There's 3 different ways to get that run window to run. So put your cursor on that toolbar. You get pop-up windows that tell you what they do. And look for the run window. So you can click on that button, hit F5, or go to the menu here and hit run. But again, there's different ways to do it, whatever way you feel more comfortable. So click on run. And this is in the program debug mode. I can now run this program. It says, are you ready to start? Click on yes. And now, because I didn't specify speed or acceleration, I'm going to move at 5% speed between my 2 points. And in my run window, I'm going to print what I told it to print. This is my first program, so congratulations. In a few minutes, we taught 2 spots. We wrote that in the code, and we printed something to our screen. That's kind of cool. When I was at Lawrence Tech, we had a 10-week class for basic robot programming, and I think it took us like 8 weeks to get to do what we just did here. So now you guys have the basics. Let me show you some other things that I want you to use as we're going to advance forward here. Put your cursor between the J and the P. Make sure it's not in the space before J, and make sure it's not in the space after the P. And hit F1, which is the Windows Help button. What that does is it brings your online help. On my computer, it doesn't come up because the help wasn't loaded, but put your cursor, build that up, and put your cursor between the J and the P. Good. Yeah, and hit F1. What that does is it tells you exactly what the robot, what this command does. Now, if you scroll down through that, it tells you how to use it in a lot of detail, or you can click on example. Engineers love examples. So click on example, and it gives me sample code. This code can be cut and pasted in my program. Again, a beautiful thing. When I was an engineer, we didn't have this kind of stuff, and it's still not available on most robots. It's this kind of samples we cut and paste and cheat like that. It's like, I almost felt like it was cheating when I first saw it. The other thing you want to do now is instead of going to under that same thing, scroll to the top of my help, and it says where it says example also says see all, see also. See also. Now these are the relatives. These are the brothers and sisters of the jump command. These are different ways to move the robot around. You got arc, you got move, you got go. Now in your jog and teach window, I can play around with these to see how different ways I can move the robot around. So what I want you to do now for 15 minutes to half an hour, I want you to teach either the E or the N or the O, whatever letter you want. Teach those points on there, and then also move the robot in different ways. So use jump, use go, use move, use arc. If you have any questions on it, go back to your help. Again, I'm trying to get you guys to rely on that help, so you lean on that help a lot. And then learn how to do the arc, learn how to do the go, and learn why you use the go or the move instead of one or the other. See the difference between those two. So you have 15 minutes to half an hour to teach either a letter or a couple letters, and I recommend doing one with some type of arc in it. So we're going to be walking around now, kind of helping you guys out as you go along. So as somebody else was saying in this class, you guys could teach it just above there. Then we could modify our Z to, so we can teach points and then we can modify the Z. There's a lot of different ways to teach points. You can move it physically, you can move it by hand, you can move it through the XYZ, you can move it by hand, and you can also edit those points. So now in your execute, you want to test out. So move between your spots, try the go and the move, and see the way they move differently, you know what I mean? So jump to some spots, or move to some spots using go and move.
Okay.
The go command is like it's got a slight arc on it because that's the robot natural motion.
Okay.
A move command goes a perfectly straight line within the tolerance of the robot. So this robot's 10 micron. I'll try to keep that line within 10
so
microns.
If I'm drawing these lines, I'd have it be move instead of go.
Yeah,
okay,
yeah.
Gotcha. So when I wrote this, I should have moved by these. Huh?
Yeah. The other thing is at the top of your program, if you're writing the E or you're writing the N, put a comment at the top. Put a single apostrophe, then say this is writing E. So it's always a good idea to comment your program. Jenny really likes those because when they look at the code, they kind of know what you're trying to do. So at the top of your before you're writing your E or the N, it's a single apostrophe, then type in this is writing the E, or marking the E. So if you guys are done doing that, run it, test it out, and see what happens.
Let's see.
Back to weight one.
Pardon me?
Let's see.
Okay. Because we specify speed or acceleration, it's going to run at 5%. So it's in safe teach mode. You're not going to damage anything. You're not going to hurt yourself. I like that. Look at this guy. There we go. Perfect. I have some spots in there. I go to my robot point file right here, or go to my robot manager and points. And I have my Z's right here. I could change all these, so I can use this as a gauge. So if I go to my jog and teach and I come down to Z, where I see I got enough of push on there, it says minus 65. I could use that as a gauge. Now I go to my point file and change this to
65.
Yes, to 65. 65. Okay, there you go. So I think now you could actually cut and paste. You could highlight that and do Control C.
I already tried it. I don't
No?
know. No, I couldn't do it.
All right, so do it that way then. Well, the other thing you guys can notice, which is pretty cool, is the way you teach the robot, you guys are unconsciously, your robot is in a certain configuration. Right now, Matt's robot's in the right, Jason's robot in the right. Actually, all you guys have a robot in the right-hand configuration. It saves it in the right-hand configuration. It's another beautiful feature about a scare robot because the way you teach the robot is the way it goes there. You don't have to have any surprises about what the elbow does. You know, robots, generally, their only concern is where the robot's end effector is. It doesn't care about what the elbow and the shoulder is, but this is, the way you teach the robot is the way it's going to go there.
So when you go to points, when it says righty, that's what it means.
It's righty.
That's what righty means.
That's what righty is.
Standing behind the robot.
Staying behind the robot, it's the right-hand configuration.
Right.
So the best way to teach your circular spot, if you got your P or your S, teach your points, the PP3, PP4, PP5, PP6. Then go to the help and look for arc and click on example. And when you click on example, it'll show you how to program the arc. So I'm going to go to my code now. And at the top of the program, one of the first things we did, we always hit reset and motor on. Those two commands you're going to put at the top of the program, reset, and then motor on. The other thing we're going to do is we're going to put a breakpoint in the side. That breakpoint is all like Visual Basic, where I'm having problems with my code, or I'm trying to teach somebody what my code is. That breakpoint you can put on the side by clicking on the side of the toolbar here. Does everybody see what I did? I can add a breakpoint on the side of my code here by clicking the gray toolbar there. What that does is it'll run the program up to that point, and then it'll force me to run line by line. So I put a breakpoint at my jump P1, I'll go to the run window, and when I start that program, it highlights the lines getting ready to execute, then it requires me to force it to execute. So right now I'm forced on jump E1. You step into that line, it moves to the next line. I'll click on the step into or the F11 key. Now it goes to E2. Move to E4. Jump to E6. So what this does is, in the previous class, we had somebody that accidentally overwrit the same point twice. So they're like, I can't draw my E. And they didn't realize that the same points was they retaught the same exact coordinates in E1 and E2 at the same, they overwrote it. So what this allows us to do is allows us to test our program and see if it's doing exactly what we want it to do. So this is a very useful feature. It's going to be coming really handy as we get more and more real-world program here. Everybody got a breakpoint in their code? Okay, so we'll hit stop, get rid of the breakpoint. Now we're going to add something else in there. After my comments, I got this as letter E. One of the other things is maybe it's not really realistic to have a marker on the end of my robot program, end of my robot. You probably have some type of dispense head or weld head, or maybe you have a grip that you're opening and closing. So we want to add inputs and outputs. Now, as I mentioned earlier, our standard controller has 24 in and 16 out. We can add multiples through Ethernet or device center or Profibus or CC-Link, or just standard I/O board. We're going to add inputs and outputs. So if you want to pay attention to what I'm doing here, because I'm going to ask you to do it by yourselves in a little bit. Right now, if I go to my toolbar and I look for I/O monitor, these are the standard I/Os right here. On my left, I have all inputs, and you notice there's some that are suggested. And on my right, I have all outputs, and these are some that are suggested, that are typical outputs. I want to add my own. So the way I add my own is I go to the I/O label editor, or Control L. Now pay attention to the standard I/O, not extended I/O, not field bus I/O, not memory I/O. If we had extended or field bus memory, we would open those up. But I only want to expand the standard I/O, which is what comes in the controller. Now, my I/O monitor tells me that everything is kind of suggested up until 7, so I'll select 8. So I have input number 8. Maybe I want to wait for a part present to be there for me to start. So I'll type in part present for an input. And I'll expand my outputs and go to bids. And at 9, I'm going to say dispense. So my I/O. So I open up my I/O monitor, and again, I don't have anything here, and on my outputs on the right side, I have nothing, and I want to add something. So I want to go to the I/O label editor. Under the standard I/O and the bits, anything above 8, I'm going to add part present. And then on the outputs, I want to expand that. Does everybody see what I'm doing there? Under outputs at 8 or 9, I'm going to add dispense. I'm going to also add maybe cycle complete. And now when I close that I/O label editor up, it asks me if I want to save it. Now my I/O monitor, I have part present and the dispense and cycle complete there. Now on the outputs, I can double click on the dispense, on the red part, on the circle, and I can force it on. So if I physically now go to the RC180 controller, there's a connector that has I/O on there. There's a pin per every I/O. That I/O if I go to my manuals and the help and manuals on RC180, it tells me that pin number 16, if it's wired properly, I can force my IO to be on. And I can check my volt, with my voltmeter, I can check it and I can force that to be on. Again, I want you to know that that I can force something to be on, and the wiring for that standard IO is inside the manual, which is under the help menu, manuals RC180 or RC90, whatever control you're running. So now I'm going to go to my code and I'm going to jump to E1. In my case, I'm going jumping to E1 and doing I'm going to turn on, whoops. I'm going to go on, turn on dispense. I go to E2, E3, E4, E5. After E5, I'm going to turn off dispense. I jump to E6, and I'm going to turn on dispense again. You notice a nice thing about EPSON is you define your points, you define your IO, and they pop up. What I always thinks about programming stuff is you forgot what you called it. And what's even worse for some robot programs is that I can't use dispense. I have to remember that output 00659 is dispense. Bless you. So I always have to remember what that was. The beauty thing is that we defined what the dispense is. We didn't have to define our bit here at the top of the program. So I'll turn off dispense. I'll move to E3. And then I'll turn off dispense. So I turned on and off. At the end of my letter E, I have a safe point defined that's somewhere above the program. Then I do my P's, my letter P. So at the end of my letter P, I'm going to say on space cycle complete, comma 5. What that does is I'll turn on the cycle complete output for 5 seconds and it'll automatically shut off. If you have any questions on how the IO works, again, you put your cursor between the O and the N, hit F1, and it tells you how the outputs work. If I was waiting for an input, like let's say I got a part present switch, at the top of my code, before writing that, this is letter E, I type in wait for SW condition. And notice is that's an input already. Double click on part present and say part present equals on. So what happens is this line here, it's going to wait to see the part present on. If that part present isn't on, it's not going to go to the next line. In our case, I probably don't want it to be on because I'm not wired with anything. So I'll leave that as off. Or I'll comment that out. I just wanted you guys to see how an input is handled. So what I did so far then is I turned on, defined an input and output. I added that in my code. Now it's pretty typical inside your IO is that I have, it could be vacuum, it could be something else that requires some type of delay. It's pretty common that you have like a wait 0.1 seconds or 0.5 seconds or 0.3 seconds. So I'm going to go inside my code and add that also. So I'm going to turn on my dispense. I'm going to say wait 0.1 and wait 0.1. Every time I turn it on or off, I'm going to wait 0.1 seconds. So now it's more real world. So what we did here then is we did the breakpoint. We added, we defined our inputs, defined our outputs. We added a little bit of weight. So we're getting pretty complicated. We're starting to get some level of complexity that's starting to be more and more real world scenario. After I do this, the next thing I want to do is, in the real world, is that I'm actually going to run this over and over again. I'm going to set for part present and do this again. So for release it, say cycle complete, release the pallet, wait for part present, do this whole thing again. So I'm writing EPSON every single time this part comes into my station. So I want to type in some type of infinite loop. There's different ways to do some types of loops. In Fortran 77, there's something called the do loop. Pretty easy. So at the top of my program here, I'm going to type in do space, and while / until condition comes up. I'm going to say do while I'm going to call some integer, some letter, I call it cycle. Cycle equals 1. So I just created a loop. Now what I want to do is I want to cut all this code, highlight it like I do in Microsoft Word. I want to cut it, tab across, and paste. And Professor Whitman at Lawrence Tech would give me knock a grade off if I didn't indent that across so it looks pretty. So again, going back to my code here, I have do while, cycle equals 1. I jump E1, on dispense. It's pretty cool. It makes a lot of common sense here. Now, I'm going to do this on purpose. I'm going to create an error on purpose because I want you guys to see how errors are handled. I'm going to run this program and I'm going to get an error. Okay, so at the bottom of my code here, you see it says error 3052 main program line 8. Variable does not exist. When you get an error, you can double click on that error and it throws you to the line that error is generated from. So it says cycle equals 1. It does not recognize what cycle is. Cycle is not a robot syntax. It doesn't know what cycle is. I have to define what syntax is. In our robot language, you have different types of variables. You have integers that are whole numbers. You have reals. You have booleans. A real could be is a decimal. Boolean is true or false. Cycle, in this case, it's either 1, 2, 3, or 4. So while cycle equals 1, I'm going to say integer. GER, and I'm going to say cycle. And then I'm going to say cycle is equal to 1. So if everybody's looking at this now, it says, that line says integer cycle. I just defined what cycle is. Now I set cycle to 1. Do while cycle equals 1. Because I didn't say cycle equals cycle plus 1, it's always going to be 1. Now I have an infinite loop. So now inside my program here, I can run this and start it. And it's going to do this gazillion times until I force it to do something different. Either by hitting E-stop, or if I had my input wired, it would only do it once and wait for that part present to be there. So if that's not enough for you guys to chew off in one 30-minute session, I'm going to add another thing. I'm going to go to main program and add another feature on here. So you guys know I'm going to leave this open so that way you guys can glance back at it as we're writing code. After my reset motor on, there's a couple commands that require me to go faster. By the Robot Industry Association for safe mode, I have to specify anything. Right now, anything that's higher than 5% speed, I have to tell it power high. So I'm going to type in power space. Actually, hold on. I'm going to backpedal a little bit to get you guys to see what I'm talking about. So if I run this again in infinite mode. So again, this is running low power mode, 5%. Well, I want you guys, if you guys want to look at me for a second here, when this guy's moving, if I pull on the robot, it's in safe mode, 5%. Its power's low. I push on the robot, that thing's faulting out. It's not going to damage anything. It's not going to damage itself. It's not going to damage me. Again, because it's low power mode. So I wanted you to see that even though I got a real program running, it's running infinite, I can push against it and it'll servo out. And my error comes up. It says motor torque output failure in low power state. It told me there's a problem there. I can't do that when I go to power high. So as a rule of thumb, whenever you change your program, always run in low power mode. The most common problem with most common crash scenario is that people they're really excited about what they did. They run in high power mode and they've crashed the robot Z-axis, or they crashed the robot somehow. Always run your first cycle in low power mode. In fact, even in production, we had a guy here this morning, even in production, it's not a bad thing to run your first cycle in low power, because you're not going to damage anything. You're not going to damage tooling. You're not going to damage the robot. You're not going to damage everything. If your first cycle is in low power mode, you get no errors. Now I start doing where I got this infinite loop. So a good rule of thumb is maybe first cycle, even in production, you run low power mode. There's different ways to avoid crashes and to keep that robot safe. You don't want to crash the Z-axis too often because it's probably $3,000 to $4,000. I think some of them are $5,000. So that could be an expensive crash, and nobody ever fesses up to being the guy who crashed that robot. So generally, you come in the morning and you realize some low power torque error, and people don't know why, and nobody wants to admit to what happened. So we're going to add 3 commands here. After reset motor on, I'm going to type in power space high, and I'm typing speed space 30. I'm going to type in accel. So speed and acceleration are 2 commands that are required to be faster. Now, if you look at my screen here, you'll see it says speed and acceleration is bold. So I'll type in 40. As soon as I put the comma, the decel is bolded. So it's telling me it's looking for some deceleration. So I'll do 35. Now I can run faster. Those 3 commands are required to run faster. However, if I don't have this power high command, it's never going to run above 5%. Again, this power high command is paramount. It's kind of like what makes it go anything above 5%. It's a good practice. We tell people to put a comment in front of it the first time you run it, and that makes it a comment instead of an actual command. Oops. All right, so now I'm going to run it. And I know I'm not going to crash because I already ran it in low power mode. Now my robot motion is pretty inefficient because you see my Z-axis is always going up to Z equals 0. So far I have not optimized that program. I asked you guys earlier, what do you want to do when you're, if you're trying to achieve aggressive cycle times? Think of yourself running around a racetrack. If you're running a quarter-mile track versus a 1-mile track, you're going to get faster times, hands down. So if you can design things so they're closer to each other, if you design things so the weights are lighter instead of heavier, then that can always make things faster. So I'm going to leave my program open. If you guys want to add those features in your program, I'm going to stop and let you add that in there. So I'm going to go to my program, leave it open so you guys can see that stuff. Now, if you guys want to get fancy, what you can do is you can say do while I is less than 10, and then add cycle equals cycle plus 1. So I can increment up or subtract and then only do it 10 times. But again, this is just an example. This is an infinite loop. You could do a loop where you have multiple times. And if we have time, I'm going to show you guys how to do a pallet where we have a pallet with multiple parts. One of the things that people use a lot of is called timers. And it's common because I want you guys to go back and use a timer. If you guys are looking at buying a robot, pretty common is that you want to get some type of guess at what your cycle time is going to be. So you can take this code and go to the simulator, have a robot that fits your work envelope based on your reach and your payload, and figure out some rough cycle time by picking the worst spots. Maybe I'm doing a tray. I want to go to the farthest point of the tray, my conveyor location, and figure out how much time it's going to take to do that. So a pretty common thing to do is use a timer. If you guys want to go type in timer, TMR, and in your case, Ricardo, if you go to main program and type in go to help, actually. Go to help. I want you guys to find it. So after I leave here, search, and type in timer. Or TMR, I think is the no topics found. Type in TMR. Try that. Or anything with T and then list topics and see what comes up. There it is, timer function. So,
TMR function?
Right there, TMR function.
Oh, here.
Yep. So if you want to open that up so we can maximize it, and you see it says click on example, and it says timer reset 0. So this resets timer 0. Then it says print timer 0 divided by 10, calculate display time if I was doing 10. So TM reset 0. So I'm going to add that in my code. So if you want to help me out there, Ricardo, it's TM reset
0.
Reset 0.
Comment.
So what's that doing? What that's doing is it's resetting timer 0. I can have timer 1, 2, 3, or 4. Now at the bottom of my cycle, after I completed my cycle.
So that's the label of the timer.
Pardon me?
The label of the timer.
It's this one, print timer 0.
Okay.
So it's print. Then what to say? TMR.
Yeah, PMR.
Yeah.
And,
0,
0.
like this. And then it says divided by 10 if we had 10 cycles. But in our case, I'm only having 1 cycle. I'm going to print the timer between every cycle. So now if I run this program, at the top of my screen, it's going to do the first motion. And it's going to print 7.613 seconds. That's what it took for me to do that. So I'm going to have you add that in your code. Now, one of the ways to optimize my code is by adding speed or by making this more efficient. So I'm going to stop this code, go to my main program. Now, a good way to figure that out is look at your z-axis. On mine, look how high my z-axis is. It's bringing the z-axis all the way up, over, then down. It's a lot of wasted z-axis motion. So I go to my robot manager, go to the jog and teach window, and what I can do is I'm going to bring my z-axis all the way down, and on the z I can use my current position as a gauge to see how much space I have. So right now my z is minus 175. Really, I could be up at minus 170 to be really efficient. I want it to be really efficient. But what you want to do is if I have obstacles in the way, if I have a tray that comes up 10 millimeters, I obviously have to clear that tray. So when you're doing a cycle study, it's not just a 2D top vision that's really important, the top view. It's also the side view because I have horizontal obstacles I have to overcome. But to make my program more efficient, I'm going to look at my Z right now. I'm at minus 170. Just so we can see it, I'll do Z's minus 160, which is right about here, just a little bit off my paper. I'm going to go to my main program, and after timer 0, I'm going to type in lim Z. What that does is it limits my Z-axis. My Z-axis won't go all the way up to Z equals 0. It'll go only to minus 160. So I'll type in lim Z minus 160. Now I have to be sure that my Z-axis is between minus 160 and minus 170. If my Z is at minus 130, I'm out of range. So I have to be between those two for that function to work. Now again, I want you guys to pay attention. When I run this, it's going to print the time, but I'm also going to turn the I/O monitor on or off. So my cycle complete and dispenser is going to turn on or off. So I'm going to run this. So watch the difference in cycle time here. My dispense is on. My dispense is off. Dispense is on. 5.846 seconds. I wait 5 seconds to tell it the cycle complete. Wait for the next one. And now it tells me my E1 is above my lim Z value. It's telling me, hey George, you're dope. You taught the E1 above the lim Z value, so it's not going to work. So I'm going to stop it, go to my point file, and I'm going to see E1 is at minus 178. So maybe I want to change I want to change that location. Do you guys see what I'm trying to do? So let's optimize the program by adding the lim Z function in there, also putting a timer in there, and seeing how efficient we can make our program, see what kind of time we can cut. Because this is something you guys are going to face in a production environment. So it's only going to take you a little bit. I'll leave my program up and you guys can try that on your own. So
Okay.
if I want to start timing at the start of my E, maybe you want to figure out how much time your E takes compared to your P. You can say timer reset 1, timer reset 2, timer reset 3. So maybe you have one timer, timer 0 for E, timer 1 for P, timer 3 for S. You guys, does that make sense?
Yep.
So I gave you an example here on the screen then. You have your timer reset 0 for one letter. You guys could add multiples for different letters. And you can compare your times on the different letters, how much they take.